computer here, click start recording. Okay, welcome everybody. Tonight is the 8th of June, or Wednesday if you're ahead of us in a different time zone. This is Dallas Personal Robotics Group Builders Night or Day Virtual. And I'd like to welcome everybody. We're going to do the usual where we go around the table and talk about the projects we've been working on, any challenges or just interesting semi-related to robots topics that we have to chit-chat about. Just a brief note on upcoming calendar. Well, actually, for the past, you might keep in mind that one of our presenters arranged a Spark Fund discount code. So just a reminder that if you want to purchase a Spark Fund original, this code's available for us to use since we had an ambassador from Spark Fund present. Coming up on this Saturday, the 12th of June, happy to announce we have David Anderson presenting. David's a longtime and very storied member of DPRG. He's got some really cool robots, very well executed in pretty much every sense of the word. So he's going to talk to us about how to navigate without making a map, and at least how he does it in his robots. And I know a lot of us are really looking forward to that. Next month's session on the 10th of July, in lieu of the regular monthly meeting for DPRG, we're going to cross-post and get as many members from DPRG as we can to flash mob on the Seattle Robotics Society Robothon. So it's a cool virtual event that's being hosted. I know I've signed up to present one of my little robots, so stakes in the ground there, and I hope we get some other people to cross-present as well. That would be cool. And then as we've been focusing on outdoor rovers this year as a kind of a way to get past COVID, we figured the first physical gathering would be outdoors. And that's looking good for the 21st of August here in Dallas. And we also have some rules so that people can participate virtually. And so we have all kinds of ideas like that going on. So with that in mind, I am going to introduce myself. I'm the current club president, Carl Ott. Ask if there's any questions before we just dive right in. Okay, hearing none. So this is one of those nights when I need to step away for an hour or so you all are on your own. And I would just ask who wants to lead us off and talk about what they've got done in the last week or any questions they might have. Doug. All right, my friend, take it away.
Okay, so I don't have too much to do, so I'll have to turn it off to somebody else before you get back. Two quick little updates. I've started my Instructables telepresence robot. I've got the wheels attached and the wiring set up, and it actually drives, which I'm not going to demonstrate today. And working on getting it ready for the July 10th thing at the Seattle, so I can show our telepresence robot. And any questions about that before I go on?
So that's not a basket case then?
I'm sorry?
It's not a basket case.
No, it's not a basket.
You got a basket on the top of it.
It is a plastic tub, as the Instructable showed. I've modified it some from what Instructable had because I didn't like some of its things, and I may change out the motors. I haven't decided yet. It's really slow, and I know certain people who I won't name but live up in the Northeast might get frustrated with its speed.
Doug, I have a suggestion. You've got that big tub. What I would think is I would build a very, very small robot, a tiny floating robot, fill that tub with water and have an inverted submarine robot with another robot floating inside of it.
You know, I did see an underwater robot design, but it's not going to help with our telepresence to do that.
It's sort of like a bathtub robot with another robot in it.
Murray's going for Inception. Awesome. Yeah. You know what I heard initially was, what? It's not a basket case? I'm like, guys, we're looking at a whole screen full of basket cases. What are you talking about?
Well, the other thing that I had was for John Gauthier, and I may have mispronounced his name, but let me share my screen. I found something that I thought he might like. And let's just see here. I should be showing this review of the T-Hine cable extension kit. This is from the Raspberry Pi magazine, and it shows this cable attached to a camera. And the whole point of this is that it can be 20 meters away, the camera from the Pi, just in case he has some outdoor thing. He doesn't want to put all of the stuff by the camera.
Is that a PoE interface?
It doesn't say that. It's a THINE interface, and what they do is they have proprietary boards here that they turn it into a Cat5 network cable to do the transmission. See this here, LAN
Yeah,
cable?
That's kind of odd. I haven't heard of that standard. Maybe it's something similar to PoE because obviously it has to provide power, and that camera does take a considerable amount of power.
Right. And they're not showing that it's got external hookup in this little example that I looked at. But I just thought it might be something you'd be interested in double checking.
THINE cable.
Yeah, I'm going to post this link here in the chat when I finish.
All right. Thank you. I'll check it out.
I've stopped the sharing, I hope. And I'm back again. And so that just seemed like something you'd be interested in since you have that remote camera application.
Yep. I'll look into it. But if it's the PoE solution that I had looked at was not very viable because it runs off 24 volts and generates all sorts of heat.
Wow, yeah.
And it's a hat that sits on top of a full-blown Raspberry Pi. So lots of reasons why the PoE solution wasn't viable. But that might be worth looking into.
Might be. I don't know. It's like $50-something, and the Pi's about that too. So it's kind of a question of what are you willing to lose?
Yeah, unfortunately, that project can get expensive depending on how much resolution you need. And matter of fact, I just bought today. I just bought another camera.
Okay. Well, we'll let you take over shortly, and you can talk to us about that if you're willing to go next.
Well, there's not really much to show. The camera I bought cost about $85, and it's got. The reason I went with the new camera is, although the Raspberry Pi high quality camera comes with it's not IR cut. It's got an IR filter in there.
I remember you talking about that.
It does still respond to the infrared illumination that I supply. You can see the license plates are really bright when I have the IR on. But the problem is that only works for the license plate. The rest of the car is still fairly undetectable. Matter of fact, I was doing test drives past my mailbox of my own car last night. Most of the time it cannot see motion because most of my car is invisible.
And it's detecting motion by the change in what's in the video?
Yeah, it's looking at changes from frame to frame. This new camera I bought has, it's a high quality camera, 12 megapixel, and it has an IR cut filter with the motorized filter built in and a light sensor. So it automatically switches during low light. It actually flips the IR sensor out. I'm sorry, it flips out the IR filter when it reaches low light conditions. So, and it's the same footprint as the camera I'm currently using. So hopefully that will give me a lot better performance.
Well, I'm still looking forward to seeing how you work out with that. I'm planning on putting some sort of dash cam in my Jeep. So I thought it would be similar, but not quite the same as what you're playing with. And that it's remote, it's autonomous, and we'll see what it does.
Well, I've been playing a lot with Raspberry Pi cameras. So anytime you want to talk, chat about stuff that I've discovered during my journey, just let me know.
Okay.
I mean, my latest, all the printing you hear in the background, I don't know if you can hear that, is I had to design and print an entirely new box because for about the fourth time, I got moisture inside the box. And I thought I had everything sealed. I mean, every seam that I can imagine on there, I had filled with clear silicon sealant. And then finally decided, you know what? Redesigned the box and then put epoxy resin on the outside of everything. Because I think the problem is that even though I can't see it, there are probably some seams between the layers of printing occasionally, probably open just enough to allow moisture to get in.
So are you shooting your video through a plexiglass to keep the water out?
Yeah, I just cut a little piece of Lexan here that goes over the kind of at an angle here to decrease reflections, but that works just fine for visible and infrared apparently.
It's not giving you any degradation in the video quality?
No, it's pretty transparent and pretty clear.
Good to know. I was wondering what I was going to put in front of mine.
And you know, it's Murray would probably say to me, "Why are you 3D printing your box? Just buy a metal box with a seal on it, cut holes in it, and be done."
He might.
Actually, I was gonna kind of come up next because this is actually the beginning of a post office robot.
Oh.
Or post box robot. So these boxes have a O-ring seal. They're about $20 in New Zealand, so they must be 15 or something in the US. And they have a Lexan top. They're entirely, I think, until you drill into them, once you sealed them, they're almost entirely waterproof. I don't know about it putting under the, under like 1 meter under, but you could certainly hit it with a hose. It wouldn't get wet on the inside because there's a white O-ring goes all the way around. And what I'm going to do is I'm rebuilding my post box with this on the inside aiming down. And I've got one of these little tiny Pi Zero cameras that's going to look through the Lexan down into the post box to tell me if I've got any mail. And then I've got a PIR sensor. And what I'm going to do is, I don't know if you can see the little black board that's in there is actually I think it's a 10 amp relay. So what I've got is when anybody walks by the post box, it's going to turn on the relay, which will switch on a 2 meter strip of LED light so that my path will be lit at night. And I'm also going to put in one of these little 15 centimeter IR detectors so that if the post box has anything in it, that will block this thing's ability to see light, and it'll send me a message. So basically, I'll have Wi-Fi connected, mail detecting, IR or PIR detecting people, light, and a camera to see what mail. If it's a bill, I'll just avoid it. So yeah, that's my post box robot project.
Cool.
Kick it out of the mailbox.
I was launching Fusion 360 and it got thrown out when it launched for some reason. Had to rejoin.
But I can recommend these boxes. They're great.
Yeah, well, Doug.
Put it in chat what that box is.
Yeah,
I don't know. I buy them here in a company that's an Australian, New Zealand company called JCar, and they don't brand anything. It's just a JCar, but they're obviously buying it from somebody else. But they have a brass insert into what is a very, very high quality, kind of a cream colored plastic with a Lexan front and an O-ring. And I don't know where you'd get these in North America, but they're really good boxes.
But it's not 3D printed. What are you thinking?
Neoprene? I don't know what the heck it is. Anyway, it's this stuff.
So do you know what the original purpose of the box was for?
They sell them in about 4 different sizes, from one that's about half this big up to even bigger. And they're just considered project boxes. Like you used to be able to get something like that at Radio Shack.
Oh, Radio Shack. Okay.
Well, yeah. I don't even, this is not Radio Shack, but I don't know who makes them, but I'm sure if you went around on the internet, you could find something because they're very, very solid. I mean, they're really high quality. Considering for $20, it's really good, actually.
Are they plastic or is it metal? I can't tell.
No. Sorry, they're plastic. And
okay.
They've got a brass insert in the corner. They're quite strong and they reinforce, and they have little rails on the inside so you can put PC boards in upright. I screwed mine to 4 little posts on the bottom. They come with or without these attachments on the side, these little flanges. And then they have, I think this is Lexan. It's quite high quality. So I'm putting my camera through that rather than drill a hole. And the only hole I'm going to have is a grommet to take the 12-volt power in and the signal back out to the LED strips. So
Yeah. Can you see my screen share?
Yes.
Yeah.
Yeah, this is my box. The Raspberry Pi goes down here. Power comes in the bottom. Then I've got a shroud for the camera. The camera goes in the midsection, and then I've got the IR illumination at the top. It used to be that I had a top on here with the infrared and camera that would rotate, but that was just too many seams to have to seal. So I've changed the whole design where it swivels on this pin here mounted, where it's mounted to the mailbox.
About how big is that?
That's about 9 inches tall.
Okay.
but it will be visible on the street, right?
What will be visible on the screen?
That unit will be visible on the street.
Under his mailbox.
Well, yeah, I mounted it on the side of my mailbox facing down the street.
Okay. Well, the only thing I can say is I don't know if you guys followed the news, but there was that one. I think they called it a hitchhiking robot. Did anybody follow that? It was a hitchhiking robot that was left out. It went all over Europe, and it had instructions on it to what to do. You put it on a train or you put it in your car, and you travel it around, and it kept track of where it was. And it traveled all over Europe, and they took it to, I think, Philadelphia, and it was only in Philadelphia for one day, and someone killed it. Some guy stomped on it, broke it. So the only thing I'm thinking of is that you put that thing out on the street, anybody notices it, they'll probably destroy it.
Well, I've had the prior version out there for probably a couple of months while I've been working on it. And one of the requirements is that I don't put too much money in it, because yes, there is a possibility that someone will just plain destroy it for fun. So, and also,
people are jerks, right? People are jerks. Who knew, right?
Yeah. So I've got a little locking mechanism on the bottom, so nobody can just unscrew the pin to remove it. Or even with a screwdriver, I've got the screws that are mounted to the mailbox hidden behind the attached box. So even with a screwdriver, you couldn't get it loose. I mean, they'd have to put in a lot of effort to steal it. You printed with PETG, it's hard to break.
The only thing I can suggest is I would make it much less obvious. My little post box robot is entirely hidden. You can't even see it when it's there. So if you can see it and someone decides to take it or destroy it, they will.
Well, I don't live in Philadelphia, but I've had tried to put new post mailboxes on occasion out in my front, to get my mail. And almost invariably, anything that I put out there that doesn't look like it's all beat to shit gets run over in about a month, if it lasts that long. I literally have a 3-inch that when I bought the house, the guy got up and had a 3-inch, like 1/4-inch steel tube that goes 4 or 5 feet tall, and 3 of it's probably in the ground. Has a 1/4-inch thing built on top of that for the mailbox section. And about literally a month after I bought the house, somebody ran right over it. That pipe is still at an angle like this, because I'm still mad about it, and that was almost 20 years ago. And
well, if you fix it, you need to put a camera out there to see if it's the post.
Well, there was oil dripping from around the thing, so whatever didn't go very far. I have a little solace with that. But every time I've ever tried to put any other mailbox out there, it literally lasts weeks, if that long, before somebody runs it over. And I'm
Harold, the one thing, I don't know if I went to high school in Iowa, and there was a real sport going on in our neighborhood where people would put M80s in mailboxes just to see how big the boom was. So, explosives in mailboxes is kind of like a tradition in the U.S.
Well, no, and I get that. I would applaud that. That's what was happening. They're literally running them over.
But see, now here's the thing: is I don't want to. One of the things I wanted to do is to kind of keep it, even though it's kind of big. It's got to look fairly low key and like a custom job. Because if it was just a Ring camera, somebody would go, oh, that's a Ring camera, and they would take that, right? But if it's something that they don't recognize, the chance that they could resell it is probably pretty low.
Yeah, I'll give you that, John.
Our area are brick columns, but even those sometimes get run over.
I'll give you that, John. If for the common criminal that would do that, if they don't think they can fence it, they're not going to bother.
Yeah, like for example, one of the things I thought about was, well, hey, why power it from the house? Why not just put a solar panel on top of the mailbox? That will really draw attention to it.
Yeah.
So that's not
Well,
an option.
and also they may know what a solar panel is because they've seen solar panels.
Yeah, they take the solar panel.
Mm-hmm.
I'd suggest reflectors for Harold's mailbox. It could just be more that little street you're on is dark at night.
No, I have a whole tree that has full of reflectors on it. I've got a full tree full of reflectors and a couple other reflectors. They still run over the damn thing.
My dad solved that. They used to live on a corner in California, and he just put a couple of very, very large rocks where in the garden they kept driving through. So they did it again, they'd hit a huge stone, you know?
Yeah, I know. I've got some neighbors that have done that same thing up the street. I just
Anyway, we are so far off the topic of robots.
Well, right, kept in on that camera business.
I actually added up all the cost of the parts just of the camera box and the camera, all the components, and it comes out to about $200 worth of hardware. And now that I'm getting a more expensive camera, it's probably around $225. So,
And you just announced that on the internet, so it's gone.
well, it depends on how many people are working here.
Where do you live?
To cruise by, huh? Yeah.
You go to my website where I'm posting all the pictures and find out exactly where I live.
Hey, well, it's YouTube. You know, people can put. Never mind. That joke's far enough. It's gone.
Well, I figured somebody will at least come by and prank me and put like an alien doll in front of it briefly.
Oh, that'd be funny. That'd be great.
Or do other obscene things in front of it.
Only if your first name is Ray.
There you go. Doug posted that. Was Murray? Did you post a link to the box you were? No.
Yeah, I had
I may-
similar.
I may
but
want to
they
get a
were
box like
containers,
that.
so-
Yeah, these boxes are sourced from Adafruit. If you're in Texas, so it's probably faster to get them from Mauser, and there's no cost benefit or penalty. So, and Mauser is one of our sponsors. So if you buy one, suggest you throw it towards Mauser unless you got some sort of coupon code for Adafruit. But they're very, very reasonable, 10 and 20 bucks, which I think is what Murray said. He said about 15.
Oh, and since you mentioned Mauser, I had ordered some parts for my next generation motor controller board. I ordered a current sensing amplifier chip. And originally the Mauser had shown that my projected delivery date was mid-June. They just added 9 months to the projected delivery date. So yeah, there's a shortage.
You have to look at when you're buying from Mauser, it's just like any of those companies. They're real upfront. You can look at when you're going to get delivered. Like one of these boxes has 4 in current stock, so you'd get it next day or two. I didn't check the other one.
Yeah, they had several hundred in stock, but I think what happened was between the time I placed the order and I actually got an email that told me the projected delivery date was mid-June.
Yeah.
But I guess somebody else got in line first and ate up all those few hundred parts.
What part is that? Is it just it's a straight chip for your board?
Yeah, it's a surface mount current sense amplifier chip.
Okay. I've got a few of those breakout boards, but they're all analog. They're not I2C, and I'm like, hey man, I could send you one of these boards if you really needed something. But if you want the chip, I'm in love.
No, I considered the breakout board that you can get from Spark Fun or Adafruit, but that adds to the size of project and trying to keep things small. So I think what I'm going to do is, rather than wait 9 months, take advantage of the voltage comparator on the chip, on the microchip PIC. And I think I can throw some components in there and come up with essentially a current sensing design on the same board.
Yeah. A lot of the Polulu devices or devices that they've made boards for have, current sense output of some kind. So,
has anybody else noticed increased delivery times for stuff that they've been ordering?
Oh, yeah.
Absolutely. Yeah, I correspond with the guy that runs Unexpected Maker. His name's Sion in Australia. And he's had, I wouldn't call arguments, but people complain to him that his products are taking too long, and he has to point out that he has nothing to do with the delivery times. But he said that a couple of days ago that his costs of shipping to his customers is doubled or tripled, and the time has increased, enormously. It's gone from like a week or so to maybe even a month or more. So shipping costs have gone way up, and shipping times have gone way up as well.
What about prices? Anybody noticed any component prices increasing?
Oh, sure. Yeah. Lots of stuff is
especially
unavailable.
Availability is the problem. I've shopped for a couple of things that they just can't get in inventory. 200 people are in front of me. Pandemic cut out everybody's building of things.
Yeah, well, if you're planning anything, plan well ahead. If you need parts.
Who wants to go next?
All right, I've got some stuff to show.
Go for it.
Go for it, Ted.
Yeah, so last week David wanted to see some videos of my bot, so I took some videos, and mostly I haven't really worked on a lot, but I kind of wiring up and figuring out how the autonomous driving will go. So let's see if I can present here. There we go. I'll share that. And so this is out in some tall grass here outside my yard. And it's going all right. The thing I want to show here will happen soon. I'm able to go through the grass, and then I think I'll go on the sidewalk here. And that works just fine. It's a lot less tippy now that I have a lot more weight on the bottom. So that's good. It has trouble with grass that's taller than it, but this is what I wanted to show. Like, I asked about gluing the wheels on, or the tires onto the wheels, and this is why it has a problem right there.
Yeah.
The wheel just basically rolled off. So then here I've got it on some rocks, and it goes all right. It has a little trouble tracking straight, and that's also, I think, because it's on a hill. And yeah, there's a little more of that, but it's not too interesting. Here it is on the grass. So I'm just showing that I'm going fast and it's not tipping over nearly as much. Part of that is I have the plate on the top that kind of sticks out back, and so it acts as a wheelie bar. A couple times it tried to tip over, but kind of got stuck on that and bounced back. But yeah, I'm just going over some sticks and branches I pulled off the tree there. And then, let's see, sooner or later it'll come back here. And yeah, that's I don't know, maybe a couple inches on that curb, and it just can't quite get up that far, but it's not tipping over backwards at least. And then if I go sideways, it'll go right up over. So that's pretty good. So I think I'm happy with the design now. I just have to hook up the autonomous stuff and put in a bunch of sensors, and I don't know, another month or two, and I might have it ready by August. stop sharing here. But yeah, thanks.
Yeah, Ted, that looks great. I think we talked about how the ability to go over obstacles was almost directly related to wheel size, and the only thing you could do is make your wheels bigger. So you just have to accept your limits at some point. I think you've got, it looks like it's pretty powerful. It's got lots of juice, and it can go, as long as you don't hit something bigger than the wheels, I think you're all right.
Yeah, and I don't expect in this contest, didn't really sound like there was stuff bigger than the wheels, so I think I'm good. The other thing I thought of was printing my own wheels, but that's going to take a bigger 3D printer than I have. Or not, well, print the wheels and the tires.
Yeah. Well, the only downside of that, of course, is I think David's test is curves, and I wouldn't be. There's no robot I'm ever going to build that's going to be able to get over a curve.
Yeah, no, unless I go with 6 wheels and do some articulation, it's not going to happen. So, yeah.
Yeah, it looks great.
Yeah, thanks. Any more questions?
Well, you've seen the stair climbing robots that they build that have like a triple wheel on an axle.
Oh, right.
It's the stair. The next wheel goes up on top of the stairs.
Yeah, but John, those are kind of specifically designed to be able to drive up a staircase. And
Yeah, like in the movie Damnation Alley. That's what we really need right there.
Well,
great reference, man.
I haven't seen that movie in like 40 years.
Now, imagine it's pretty hard to build an all-purpose mobile robot that is designed to handle stairs, flat surfaces, terrain, climbing trees.
Well, David's done most of that, but his robot's pretty big. I'm trying for a small robot myself.
Yeah, mine's about a foot square. I guess the wheels stick out a little further than that. I think width-wise, it's like 16 inches.
Yeah, I'm trying to think how big the J-Bot is. It's quite a lot longer. It's like maybe 2 feet or something like that, and 18 inches wide. No, he said it was square, actually.
It was square.
18 by 18.
Square, yeah.
Okay.
But I can't remember. Doug, do you remember how big it is?
Yeah, 18 by 18.
Ah, okay, thank you.
Yeah, well, David suggested I super glue the tires onto the wheels, and I haven't done that yet. That'll probably work, I would guess.
That's what I had to do. Yeah.
I'll go next.
Okay, Chris.
All right, so been spending some more time with my salvaged Nido that I pulled out of the dumpster. And let me move the camera, it'll be a little easier. But I managed to, sorry for the movement. So I managed to, you know, kind of sort of secure the Pi, and you can see the 10 AA's down there and the battery pack and a little 5-volt for supply for the Pi. So this is all tucked into the dustbin right now. You know, not super well secured, but good enough. And like I kind of mentioned last time, and let me just move back to share my screen, that I mentioned last time there is this API that the controller that's built into the Nido robot kind of gives you, sort of, I mean, quote unquote API. Again, I don't know if you can still see my camera, but there's this USB link, and it might be a little small. There's this USB link right here, you know, between the Pi and the Nido controller. And so if you can see my screen, and you know, there's a lot of code out there actually for various versions of this, and I looked at some of it, and most of it is very straightforward. And so I didn't feel the need to reuse anything, but also none of the code I saw out there kind of solved one of the main challenges, which has to do with how you control the motors, because you can't control wheel speed independently. Before I explain it a little more, you can kind of see that what you have to do basically to control this thing from Python, you end up creating your API, and what that API needs to do, right? It needs to send a command, in this case, get motors, which will come back with all kinds of status information about the motors. And then you kind of parsing it, and it comes back usually as some comma. Well, it comes back as multiple lines, and every line contains a value, sort of thing. So you send a command, you get back some ASCII text, you parse it, and out come some values that you then can use, like what's the current speed of the motors, what's the load on the motors, etc. So for things like motors and what else, analog sensors and digital sensors, I've created this simple API here to pull this information out. But again, in the end, the motors are the tricky part, and you can already see from this motor command here where it gets a little convoluted, because again, you can't control left wheel and right wheel speed independently. You can only give it a speed that applies to both wheels, but then you can say, okay, I want the left wheel to travel at a different distance than the right wheel. I mean, again, totally counterintuitive, right? That's not how we usually control our wheels. We say, okay, I want a certain speed. I don't usually go a specific distance on the left wheel and a specific other distance on the right wheel, but that's how this API works. So what I ended up having to do is, in my main loop, somewhere down here, okay, once I have my speed command, which I get from my joystick, right, then I have to sort of engage in this convoluted logic here where I then calculate sort of a distance from the speed that I the user, give it. And what I do is basically I run through this loop at some rate, and the rate kind of depends on how many commands I issue. But let's just say right now it's around 10 times a second. And so what I can do is I can give it a command to run for a certain distance with the intent of then giving it a new command before I've even gotten there, right? And so in the end, to control the wheel speed differently would be, what I was able to do is to say, okay, if I want the left wheel to go a little slower, I have to basically tell the left wheel, go for a lesser distance than the right wheel. Just a little bit, right? Just so that the left wheel, comes to a stop just, a smidgen before I'm about to issue the next speed command, right? I don't want the left wheel to just go a millimeter, right? While the right wheel just keeps on going, right? I have to just make a subtle difference in distance so that the built-in controller will effectively slow down and stop the left wheel, just before I'm about to start the whole process over again. And again, with a bit of experimentation, turns out it's not too choppy, I guess in part because of the momentum of the robot itself. It works out fine. The movement is smooth enough, all right? It's not great, but it's smooth enough. The only thing is I can't quite calculate, I can't quite say I want to go at a very specific left wheel speed or right wheel speed. With the joystick, controlling it interactively, I'm the human in the loop. I can kind of tell, am I turning enough or do I need to turn more, right? I can instantly adjust the joystick the way I wanted to. But if I had to write a control logic, if I wanted to go in a very specific arc, that would be really difficult to do, right? Because I can't, because this whole spiel about, manipulating the distance value kind of all depends on the speed at which you're going too. So I could probably figure out the relationship between all these values experimentally and create a big lookup table or see what function governs this. But again, for interactive purposes, it's not needed. Or if you don't care about the exact arc at which you're traveling, right, it wouldn't be needed. And so, yeah, so that's what I had. That was really, in the end, the only challenge. And so if I stop the sharing and pull this back up, so if I start this now, and again, in the end, I was semi-happy with the smoothness of it. The LiDAR also kicks in, so I'll talk about that in a second. So I can control it and can kind of, again, all the other software that's out there, the only thing you could do is, go straight forward, go straight back, and then turn on a dime, right? So that's what everybody else is doing from what I could tell, but I wasn't happy with that. So again, with this convoluted logic, not sure if it's evident really, but I can sort of turn in an arc, to, degree of satisfaction here. So the LiDAR is also going on. I said last time that not sure yet how I'm going to do the LiDAR, given that serial link is a little bit of a bottleneck, but tapping directly in the LiDAR be just less elegant. So I decided to use that serial link as is for the LiDAR. And it just slows things down a little bit. The main loop ends up running a bit on the slow side because it takes a while to get the LiDAR data out. So I run that main loop probably at around 10 times a second, but I'm not sure if that's fast enough to catch, me falling off the stairs or something. I haven't tried that yet, but it's good enough for this sort of just playing around. But the LiDAR data basically comes out, and right now I have it just split into. I'm not looking at the full 360 degrees of what the LiDAR gives me. I'm basically splitting it into 45-degree sections, and I'm just looking at what's the shortest range in each of those 45-degree cones, right? And ultimately, that's the number I'm recording. So that comes out to 8 values right now that I'm just printing here. I'm not using it for anything yet. I don't have any actual feedback control going on yet. But that's what I'll probably do next before I sort of put this thing back on the shelf. I just wanted to see, what's doable with this simple interface. But yeah, that's my plan. I don't think I'll do anything more fancy than just splitting LiDAR data into either, like I said, the 45-degree sections that I have right now, or maybe I'll make them a little smaller, maybe 30-degree cones, and that would give me 12 readings effectively, as if I had 12 independent, distance sensors of whatever type, right? That's kind of how I'm treating the LiDAR right now. And then build a little bit of a controller around that, and then, probably put this thing on the shelf. Or I was thinking, maybe I'll try to sell it. I don't know. Maybe some parent is looking for something to occupy their kid with over the summer break, which starts soon here. I don't know if someone is willing to pay money for this, but if I sell it with the Pi, with the battery, like ready to go, ready to run, maybe someone will give me a couple $100. I don't know. 1 hour of support included, So that's what I did last week.
Yeah, I'd be careful with that warranty, though. You don't want to get yourself tied into that one too deeply.
No, I would say 1 hour support. That's it.
I only say, Chris, you're pretty evil. Just saying right now.
Why?
Ready to go.
Because I'm going to sell it.
Take some work. If you're ready to give up on it, imagine some kid getting this thing, right?
Well, no, I'm not giving up. I mean, I'm not sort of giving up on it because of no use, because it's kind of distraction right now, right? I've been working on my Romy platform and need to get back to that. So this is just a little detour.
I apologize. I didn't mean to put words in your mouth there, man. I really did.
It was a bit of fun in the dump.
Exactly. It's just found it in the dump. Hey, you gotta get them do something with it.
Mm-hmm. I can go next because I'm pretty pretty short. I'm trying to make my robot work and that kind of thing. If you're done, Chris, I don't want to stop you from. I found out one thing this week that I already knew, and I was reaffirmed on my Twitch feed. I had 6 or 8 people watch me at one time. trying to crimp JST connectors, and they were all feeling my pain, and they were all happy to commiserate. So things weren't as bad as they possibly could be, but I finally did get them going. The other thing that came across my feed, I'm about to drop a link or two. You're like, well, why are you dropping this? This is Disney Avengers Academy opened this last weekend. Let me find my.
Is that the Harold? Is that the animatronic human they're using for stunt doubles?
Yes.
Yeah, that's pretty impressive.
It's pretty impressive. So here is what the stunt. Here's the full stunt show, but I've got this video should be. It's not queued up to it. Hold on, that's a bad link. Let me get you a better link. To
It's
where
not like having millions of dollars to spend, I gotta say.
the actual way the show works, and I'll put it right on time for you. You happy to watch the whole show if you want, because it's pretty cool. Okay, it's at time right there, and I want to show you here. Right? How can I do? I need to present now. I'm going to present my whole screen because I'm a monster. Alrighty. Sharing. And this is the link I just posted up. Okay, everybody's got that? And it's in there. There's a bunch of music and other crap going on, but if you'll watch right there where that opening is and kind of the crane thing going on, this is what happens. That is a robot. And we can go back and run that again because that went pretty quick. He does a bunch of other things too. Then he runs in, and then all of a sudden you see, come on. Oh, now you got it. I missed it. He's popped up over here.
If you remember movies from the 70s, whenever anybody went off a cliff, it was obviously a dummy.
It was obviously a dummy. Well, somebody on one of my channels got up and said, "Hey, man, there's actually more to that story," and I'm going to post that link up here as well. And this is from GAS 2 years ago, and like, how did I not know about this? And this is more of a making up. It's about 40 seconds long. So they call it Stuntronics. This is how they started, with a stick. And they keep going through and get a little better. Now they're having it land in the hole. And then this is them prepping their actual stunt show that you saw going on. And that is an animatronic, completely floating free. I'm not sure how they control it or what they do. I'm sure it's pre-programmed somehow, but I don't know much more about it than the video you're seeing right there. And that link's going in the chat too. And that's 2018. I knew I should have been an Imagineer, or at least try. This one, like, everybody always has regrets about stuff. Well, that was mine. I never even applied. And not that it's too late now, but it pretty much is. With the stuff going, I'm not moving to Florida, is what I'm saying.
Harold, I really wanted to be in the Mickey Mouse Club.
Yeah, me too.
Well, Harold, it's a small world after all. You could still do it.
Yeah, and a bright, big, beautiful tomorrow is only a day away.
Can you sing, Harold? That's the really big.
No, I cannot. Yeah. I cannot sing. I cannot sing.
You can't do the Musketeers.
No, I can't do any of that stuff. So that came across my feed, and I figured I kind of wanted to share with the group because I thought that was impressive. As get out the motion control. I know we've seen the Boston Dynamics and all that kind of cool stuff, but they are firmly on the ground for the most part. Maybe they hop a little bit. This thing's flying through the air. It's got definitely got some angular velocity going on there. It has to deal with, right? So I figured I'd share that. That's about all I really got. So next.
Well, if I remember right, it's they've actually also got a whole bunch of robots that they run around on stage, and I think they've animated. There was that Guardians of the Galaxy, and there's that little tree character, and they've animated that, and they can walk around entirely on its own.
They They
What's that?
supposedly have
Groot.
Groot, yeah.
yeah, they supposedly have a Grogu, a little Grogu robot that will look you in the face because it recognizes the face, and it's only about yay tall as it's walking around and looks right at you and will follow your face.
Yeah, they've animated animatronic Groot, who's like a natural size, whatever in the movie, a Groot that can actually walk around on its own without any cables attached, remote control with cameras and everything, facial expressions, and they're doing that with a whole range of different robots, so they can actually have a stage presentation of I can't even remember. It was like it was one of the classic Disney movies where they're going to do all the characters as animatronic.
That's amazing. It really is amazing.
With no cables. These things walk around on their own and do a theatrical play.
Well, that's probably the easiest for Groot. All he says is, "I am Groot," right?
Well,
Does he say
I
anything
am
else?
Groot. I am Groot.
I am Groot.
I am Groot. He's so expressive.
Mm-hmm.
I think the best part about Groot is when he goes, "I am Groot," and they all turn language. Every one of them just so they get that. That kills me. But I'm easily killed in a lot of ways.
No spoilers.
Yeah.
Hey guys, the Lion King, that newer Lion King movie, I thought that animation was so realistic. I don't know, it's just CGI, is it? Or it can't be real animals, but it looks like.
I don't know, the live action Lion King movie. I don't know how they did all that stuff. I'm sure some of it was.
Yeah,
A lot of it was.
It's just too many hours of CGI, so make it too realistic.
Well, what they did for the Lion King and also the way that they filmed the Mandalorian was all of the background CGI was rendered in real time using the Unreal Engine 4, I believe it was, the game engine.
Yeah, that's
okay. I'm going to jump in and mention because if you have access to The Mandalorian on your streaming service of choice, look for the extras episodes that they have. And somewhere in there, and they describe something that they call the volume. You can also do a Google search on Mandalorian and the volume. And it basically, in that, they show the progression of the guy that set up the volume for The Mandalorian and how he went from like whatever movies to The Lion King to Mowgli to whatever. And they finally got to The Mandalorian. But basically that not only is it the Unreal Engine, but they got this giant room that's the walls and ceiling are a solid addressable LED display, right? They're direct view LED displays. And then what they've done is on the cameras, they've put motion capture sensors on the cameras so that the cameras know where they are in space within the volume. And then they've rigged that up into the Unreal Engine. So what they do is they have the graphics artists portray all the scenery on the LEDs in the ceiling, and then they have whatever props in the volume that matches that, and the actors just run around in this set that's the volume. And while they're doing that, the camera people are on their dollies or they have the handheld unit. But as they move around, you see they've got real perspective because the camera knows what it is, where it is, and where it's aiming. So based on that, it then instructs the volume and the projection light LEDs to change the scene behind where the camera is viewing. So it's really crazy the way they've wired that up. And it gives the advantage of then, like usually the CGI, from what the guy was saying, usually the CGI people, they have to do all kinds of fancy ray tracing and stuff, to get the shine on bald heads, for example. They have to do all kinds of fancy ray tracing to get the ambient light. But on The Mandalorian, they just had the guy walk around with a shiny helmet. And because all these LEDs were around him with the right scene, all the reflections look really realistic. And that little difference makes a huge,
I don't mean to belittle that accomplishment, but at all. But it's amazing what you can do with almost an infinite supply of dollars and lots of creativity, right?
Yeah, just a few $1 million.
Yeah, what the hell?
Oh yeah, that's my plug. Because yeah, it was. I'm glad you brought that up, Ian. But there's a really cool view on it if you're interested in that kind of stuff. It's fascinating to see. Takes the magic out of the movie, but anyhow.
Talking about it too. It's
No, it doesn't. It
it's
doesn't.
called the Gallery or the Mandalorian Gallery or something. It's like 8 episodes long.
Yeah, something like that. It's well worth it, I thought, if you like that kind of thing.
You know, I do a little magic. You know, here, pick a card. Is this your card? Kind of stuff, right? And well, if you didn't know, I do. So the problem with exposing the trick is not that we don't want to tell our secrets. The problem is that once you do, you lose the magic. You lose the feeling that you felt when you saw this impossible thing become possible right in front of your eyes. And for a lot of people, like Carl, you just said, it kind of loses the magic a little bit once you see behind the scenes. But for magicians and people like myself, and I imagine most people that are on this call right now, it only enhances the magic because you're like, oh, that was amazing. And that's how that get out. No, they're not doing it. You had to do it. Holy crap. You know, it enhances the magic. It doesn't take away the magic, so to speak, or at least for me. I mean, it makes
for sure. Well, in there, they talk about the actors. Sometimes they forget that they're on a set because they can't tell the difference between the prop and the LED picture wall behind it. Walking into things.
Yeah, like in Bugs Bunny when he, not Bugs Bunny, Roadrunner, you know, and the Roadrunner paints the fake, fakes the fake thing to the mountain, and Coyote runs into it. There you go.
Yep.
Harold, I know what you're saying, and I don't really disagree, but I had a friend when I was living in England who was quite a master card shuffler, card trick guy. And I've never met anyone who could do what he could do with cards. And with a standard deck, the kind of stuff he was doing, he was not allowed in anywhere. I mean, he basically was blacklisted from all the casinos because they knew who he was. He knew how to mark cards, but he could also take a brand new deck that I gave him and totally with that deck
and just
do things that just mind blowing. And like I said, if he'd showed me how he did it, and he did show me how to mark a card, but even when I knew how to mark cards, it didn't help. He would still do stuff that was just mind blowing. And I actually don't want to know. I really don't, because it was cool.
I will guarantee you a lot of those things. These following words will happen when every now and then somebody's found out, either because I messed up or they went and looked and whatever it was, and I get this. Oh, is that all it is? I'm like, yeah, absolutely, that's all it is.
Well, this guy was talented in the card manipulation, like with his fingers. He could do stuff with his fingers that was, and he practiced pretty much constantly. He lived alone, no girlfriend, you know, that kind of guy. Basically, he had all the time in the world just to practice.
That's kind of a requirement for those guys.
No
I know several of them, and I know probably one of the best card mechanics living on the planet today. And I've had dinner with him and shook his hand and hung out with him. He's an amazing guy, and he can't see. He's totally blind, but he doesn't want that. He doesn't want you to know that until well after the fact. And what he does with cards, it's off the hook. I can't even. I mean, it's amazing. All right, next. Back on the subject of robotics. There you go.
Donna, you got an update from Seattle?
Yeah, Doug. So basically, I think that you joined just a little bit late, but Carl started off with a general announcement that number one, well, okay, so the SRS contest or showcase type event that's going to be virtual, that's going to be on July the 10th, okay? And all of you are strongly encouraged to enter or at minimum just attend as attendees in the audience, so to speak. And I can put the direct event link in the chat whenever I'm done. But it's definitely on. And so what Carl and the rest of the DPRG committee has decided is that the July DPRG Saturday main event is canceled for this coming month, and instead, since it's on the same date as the SRS event, and instead everyone here is encouraged to attend the SRS event. So so it's turning out to be I've got quite a good number of registrations currently. I've got eight people registered so far. And so everything, and Doug, I think that you said you were working on a telepresence design. And so if you are, and I strongly encourage you to, that would be a great project potentially to share at the SRS event. And so if you're interested, I encourage you to pre-register and get that entry on the docs for the event. So that's the SRS update.
Cool. I'm hoping I get my telepresence robot presentable in time.
Well, remember, it doesn't have to be. So one of the premise concepts that I had for putting this virtual event together is that it's kind of the idea of knowledge sharing, kind of like what we do in this meeting every week, and then on the complimentary once a month Saturday meetings as well, where we're information sharing. We're kind of, as we as builders are encountering roadblocks or issues, we talk through those. We discuss ways of mitigating the problem and then eventually solving it. Okay. And so that's kind of the premise that I had with this SRS July event, is that I'm encouraging people to present their projects in whatever matter of done state that they're in. And the idea of more sharing the knowledge that you have gleaned so far in working on that project, so that you are then sharing those learnings and skills with other interested builders. So what I'm getting at, Doug, is that it doesn't necessarily have to be to a particular done state. The more that you're just sharing the thought process, the design process, the the pieces, hardware and software that you've been able to put together, the better. In fact, that might even make it a more interesting project if you can, show all the different options and stuff that you've looked at for either hardware or software, or you know what I'm getting at?
Right.
So, okay.
And I see that Doug shared your link for you already.
Okay, excellent. Thank you, Doug. Did you have any other questions on that, Doug? Doug D?
No, I was wanting to at least make it kind of functional before I got it going. And I think I'm going to make it, unless I get sidetracked easily, and I've got a 2-week vacation somewhere in there too, and there's not many weeks left.
Uh-oh.
So I can do a current state of the thing. I need to dig out I got an email somewhere that showed how to contact you to get on the list. I didn't know if your list was pretty full.
Oh, no. Well, I mean, it is, but I mean, the thing is that if we get what I've arranged on the SRS side for the committee, is that we don't want to have this event go for too long. Right now, it's definitely at a 2-hour duration, okay, with the number of contestants that will be there. And the thing is that if we get a lot more interest, we can break this out into successive events. So in other words, like, a month later or 2 weeks later, whatever we determine to be, we could hold a second run of the event with the next set of participants. So
that makes sense.
So we can break it out that way if need be. Okay.
Anybody else want to go next? It's too early to quit. Somebody's got to speak.
I'll say something. I'm going to put a link in here. There's a show that looked really interesting for electronic fabrication and everything that Harold brought up about 3 meetings ago. It's tomorrow.
Yeah, designed to
designed apart, and it's free if you pre-register. I think I don't know if it is if you do it at the thing, but anyway, I'm linking the information here right now.
Doug, I think you can just show up if you want. It's free.
Yeah, I'm pretty sure. I wouldn't be surprised.
If you can register, it'll probably save you a little time in the walk-up booth to get a card or something. That may help you a little bit, right?
Yeah.
Time saving.
Going to be at the Gaylord.
Yep.
Yeah.
I will tell you, if you're walking through and when I was there, I had like 6, 8, 10 aisles or something, and by aisle 2, I was just blown away. I didn't know else. I was drooling out of both sides of my mouth because the floor was level. Because it was amazing on all the stuff. If you're not overwhelmed by the 2 or 3 aisles of this stuff, I would be very, very surprised.
Yeah, I'm looking one of the things that I kind of wanted to look at, there's a lot of different aspects of it, but one of the things I wanted to look at is some of the wiring ideas to see if I could figure out a better way to do wire management on my robots. So that's one of the things I wanted to take a look at. But there's 3D printing, and all sorts of other stuff too.
Yeah, Barry, you want to show up for the 3D printing?
Yeah. So but it looked like it did really look good. So I'm hoping. I don't know if I can make it tomorrow, but I'm hoping to make it on Thursday.
Oh, interesting. I did think of a question while I was waiting that I might ask Doug, because he had experience with continuous rotation servo.
Mm-hmm. Yeah.
And I've just gotten my servos so they actually run. Of course, one runs at a different speed from another. And I know you write a particular value depending if you want to stop, go forward, or backwards. I see that in their sample code.
Mm-hmm.
But I don't know what the minimum and maximum numbers are. I just have those samples. And I was thinking I would just try some numbers and see how they work. I don't think I could break it.
Do you mean, are you talking about the pulse width?
Right.
All right. So, I think it's 1.5 milliseconds is neutral, and 2 milliseconds is one direction, and 1 millisecond is the other direction. So if you're at 1, you'll be going reverse. If you're at 2, you'll be going forward.
Going to present here and show what their sample code looks like.
Yeah, and a lot of servos go outside those boundaries, so you can actually go further if you go down to like 800 or 2200.
Yeah, you can do that, but you got to be careful. Well, for a continuous servo, you don't have to be as careful, because if you were using a normal servo and you put the more extreme values in that particular servo Chinese knockoff or whatever it is that you use, you might find that you're grinding gears because you've hit the stop and you're asking it to go further.
Right.
So you have to be careful about that. And there's even some old, if you got hold of some really old ones, they were literally even 2 milliseconds and 1 millisecond is kind of is a little bit out of their range, and so you'd want to be inside of that. But for most modern servos, that's the range you can. So if you look at the speed control, let's see, give me a.
I think I'm presenting the sample code.
Okay, let's see what you got here.
And they're not going with the milliseconds. They're writing values, and I'm assuming.
Yeah, because you're using the servo control. You're using the servo libraries from Adafruit, and they take a value between 0 and 180 degrees.
Right. See, so I'm using 94 here as a stop.
Yeah. What are they? Okay, if it goes from 0 to 180, what is their neutral? 90.
94 is what he suggested. I haven't tested the stop yet.
Okay.
I tested to go forward.
90 probably is the stop. If you look on your servo and you look underneath of it, you'll find a set screw.
Yeah.
And that set screw you know, like if you say drive it at 90, if it's still moving, you can adjust that. It's actually a resistor, that multi-turn resistor, and you can adjust that till it stops if you want to code in what you want neutral to be. But like Doug has said before, I think it's Doug has said before, you change the temperature, change the humidity, change the heat, change the whatever, you're going to have to adjust that set screw again back to 0 for the environment that you're currently in.
Yeah, it's not, that's not, yeah, he's exactly right. Now, if you look at
forward section.
if you look from maximum forward to maximum backwards,
right,
it's an S curve with a steep slope through zero, okay, 0 speed, and then it goes over. Well, you see how I'm going so far over at max speed, and then I'm coming really down quick, and then I'm coming over to maximum minimum speed. So the only speed control you have is in that central part, which is a very steep curve.
Right.
Okay, and there's also a little slight deadband around 0. Okay, so
so I can tweak those numbers, see how it affects the speed.
You can actually run on the curve, and if you can feedback loop it, and I'm trying to think about it, usually you'd probably do it with an external, shaft mounted encoder, so it's not going to have a lot of resolution, but you can probably actually pit it. Okay. Now, what about the max speed and the min speed? Typical max speed and min speed on a continuous servo is 60 RPMs. So that's 1 RPM per second. So that's it. That's all you can get out of it. Now,
pretty slow. I may end up changing out the motors on this thing.
Yeah. So what is this for?
This is a telepresence robot that was in that injectables thing.
Okay. So they're using okay. The first robots that I built were continuous, and then I did something a little bit. I stripped out the motor controller board. So all it is a black box with a motor and a gear head. So it's essentially a motor with a gear head motor.
Right.
And you can do that and it's okay. So now you need a motor controller, some sort of H bridge to control it. Where before all you had to do is send it a pulse.
Right.
And it'll handle it.
Right.
So that's really, really nice to be able to just send it a pulse. And that's why I did it with my first robots, was because it was simple.
Right.
And like I say, if you can get on that steep curve, but it is very steep, so you might find that I don't know what his 90 and his 89, you might be all of a sudden from 0 to 30 RPM, and at 92 you might be actually at 60. You know what I'm saying? It's just a real steep part.
Well, on their sample code, they're going like 84 in one direction and 104 in the other direction is what they're thinking is their movement speed. Right. So I might just try moving those numbers a little bit away from the 90 to see if it increases the speed a little.
Yeah, and like Harold said, there is a nulling on most continuous robots, continuous rotation servos. There's a nulling potentiometer usually stuck in the back.
Right.
And you just tweak it. But probably the best ones are the ones that come from Parallax.
Yeah, these are Parallax.
Yeah. So those are pretty good servos as they go. But I don't believe they're metal geared. I think they're plastic geared, if I remember.
Probably.
Right. Yeah. So they're pretty light. And another way you can go if you absolutely want to stay away from having a motor controller, though you're really doing that. Vex makes a 1.5 amp small little module. that essentially takes the pulse width and turns it into an H. It's got a little H bridge on it, and it turns it into an H bridge. So if you have other small motors, you can use those little, and I think they're about $9 a piece. And so you can use them. I can't remember what the VEX number is, but I could find one while somebody else is talking and put it out there. But I've used those too. Those are kind of, where when I was coming up, like I said, I was really afraid of using a motor controller. So I, was using continuous rotation things, and then I went to this little VEX controller, and so I didn't have to change my code any. So it's something to think about. I don't know. You got any other questions? I can.
No, that was the only thing. I was planning on changing those numbers just to see how it affected it, and I was hoping that I couldn't break it by putting too far out of a number. And keeping 180 should be easy.
Yeah, you should be able. The numbers they're giving you, I think, are the edges of the curve.
Right.
Otherwise, they're giving you the first bottom number and the first top number. So if you stay in that range, you're absolutely no problem. But you might, just for the heck of it, take a number that's like 15 or 20, and I bet you'll see the speed doesn't change.
Right.
But it's already maxed out.
I need to tune them a little bit because one motor is a little faster than the other. So I need to change the numbers just a little bit to straighten it out.
The only way that's why they're great for little things like starting a line following, where you don't need, where other things are controlling the speed. You're getting feedback from other things and changing the speed of the motor. But if you're trying to do like a navigation robot, you're gonna have to, you've got to have some sort of feedback loop to get them to go the same speed. I would say you'd be better off with an LN 295 and and a couple of those little yellow motors.
Yeah, that's actually, I have a package of them I'm thinking about changing out.
Yeah, but you've seen this robot that I've been screwing with, and this one uses the DF robot one with the encoder on the end of it. And it's a little bit better quality than those yellow motors, but not a whole lot better. But it does have a good encoder on it. And that's why I'm having an outboard, but most of my robots don't have the outboard. So outboard bearing, I should say. So that would be the next step up, and then probably a Polo to a 20 millimeter motor would be the next step up from that.
Yeah, I looked at those yellow jackets that Ted was using. Those look like pretty powerful motors.
Yeah, they're probably a little overkill for this, but hey, that's how you do it for the fun. You do it for the fun,
Yeah, my robot weighs about 15 pounds now, and they're overkill for it. Of course, I have 4 of them.
And it zooms along in the video.
Yeah.
We'll call it design overhead.
Yeah.
But those motors are like $50 a piece, aren't they?
40, but yeah, they're not cheap.
Yeah.
Well, I don't know. Polo just had I guess it was a Memorial Day sale. So if you didn't take advantage of that, you missed it for till the next sale. They were giving, I think, a 25% discount on everything.
Well, the benefit of the yellow jackets and some of the other motors that are sold at Servo City and Go Builda is that they do have a line of ones with ball bearing on the shafts, which is something, Doug, you've talked about before too. And those are really durable and quite expensive, but really well-made motors. I've been kind of saved from spending any money because for some reason in the Southern Hemisphere, the Go Builda website was broken for about the last 2 weeks. I couldn't actually buy anything, and today it came back online. So,
oh God.
Yeah.
It was doing you a favor, Murray. It was doing.
Yeah, they were really, because now I can see all the things I want to buy, and like I said, last time I bought from Servo City, it was all the Imperial measurement units, and I looked back and it was a $240 order of parts with $120 of shipping.
Wow.
So, yeah, and they don't have a good shipping option. So what I'm going to do is, turns out Ethan, one of the guys at Go Builda, I think he's sort of like the main guy. He's joined the personal robotics chat. and I'm going to see if I can talk him into figuring out some other way to have like cheaper, like U.S. Post or some other cheaper way of shipping. Because if they send it through the regular way they do within the U.S., it's fine. But if it comes all the way to New Zealand and it's any sizable package, the shipping is going to be just outrageous. But I'm almost ready to make that order, and I can now. It's kind of scary.
Murray, I don't know if it applies to overseas, but in the United States, they have what they call, well, it's a small box that you can put whatever you put in the box, and it could be bricks. And if it fits in the box, it all ships at the same price.
Yeah, flat rate shipping.
By volume, in other words.
Yeah, it's by volume.
Yeah,
and
must want to ship that, yeah.
So but most people's orders, you buy a few little tiny things, you put it in that box, it's very expensive because you can just put those two little things in an envelope and save a lot of money. But if that shipping price is good all the way to New Zealand, then you might actually ask them about, what do they call those boxes? I can't remember.
We've actually got an option here where we can actually have stuff shipped to a secondary location, and then the New Zealand Post will actually pick it up and ship it here. But the problem, which wasn't true like a year ago, is that the cost of shipping has gone up so much now that it's just outrageously expensive to ship anything of any size.
Yeah, Doug, they probably also save money. I imagine all the boxes are the same size.
Well, it's done by the post office.
Yeah, I think it's called like one rate or something. Yeah, it's a
flat rate. Yeah, I think it's called flat rate.
Yeah, if you make all the boxes the same size, then there's no problem stacking them, and you can efficiently make use of space. And
yeah, I mean they have some that are, like pretty big. You could put 2 phone books in them, and then they have one that you can put a CD in. I mean, they have several different sizes.
They're banking on people not shipping gold or lead. To make that
flat rate boxes. I think that's what they call them. Flat rate.
I don't think they go overseas with those, though.
I don't know, but if they did, that'd be great. Yeah.
I just want to get this telepresence robot done because I'm kind of champing at the bit to get onto my next thing, which I'm going to present real quick here.
Okay.
All right.
Somebody needs to make a sailing robot with a solar panel on it that will deliver to Murray.
That PVC pipe,
yeah.
Mars rover. I want to try it.
Oh, cool.
Watch this go up the stairs.
Cool, and it's using those standard wheels for the RC cars we get from AliExpress with that hex nut thing in there. That's a pretty elegant solution to a problem there.
Yeah.
You can put a soundtrack in there so it'll have a sound system and
a mirror ball.
Get Murray to groove out like that there every time you run it.
I'm going to slip that into the chat, but I think that'd be kind of cool. I cannot get it done in time for August, but I think it'd be kind of cool to play with.
You gotta add a set.
It might make a telepresence robot.
The only thing I have to say is I've had chats with people about like PVC pipe and stuff like that, and actually in terms of strength, aluminum channel or even those little aluminum box channels, like the aluminum box, I think it's called a aluminum box channel, are extremely light. They don't cost much, and they're a lot stronger than PVC is.
Yeah, I wonder where I would get it though. I know where I can get PVC.
I put it this way: I can go down to the hardware store here in New Zealand and buy. It's a rectangle of aluminum with maybe 1 mil walls, and it's extremely strong, doesn't bend, and I can get it here in my hardware store. You can get it there, I'm sure.
Yeah, we can get it at Home Depot.
Yeah, Home Depot, Lowe's, Ace Hardware. I'll carry that.
When you say cheap, how cheap is that aluminum compared to PVC?
Well, PVC bends though, and it's quite heavy.
Okay, so let's say that you don't have pretty stringent strength requirements, all right, and either will do. What's the price comparison?
I don't know exactly, but it's not particularly expensive. I think that like a 1 meter section of that stuff is like about $25 or $30, and you would never. Maybe you'd need a couple of those, so maybe $50 worth of aluminum. It's not that much.
Okay,
and
well,
it's a lot lighter. And
that's a big price difference compared to PVC. If you don't need that strength, you can really save a lot of money on PVC.
Right, but you have to realize you're spending like probably over $100 on motors just for the 6 motors and speed controllers and everything.
Yeah, it all adds up.
Yeah.
Just looking like an interesting project. Everybody kept talking about the rocker bogies. I wanted to try one.
I think I'm going to jump in then. So I've been working towards Columbus, looking for a cheap and easy way to do it because I don't have much time. It turns out I had even less time than I thought I did, so we'll see. But I started off with this is I don't know what it is, 10th scale or something, outdoor racer that I got from Mr. Anderson. And I basically took it down to the chassis and the motor and the suspension and the wheels, and I put in a new steering servo and figured out how to get the 4-wheel drive bar reattached after in and out. And I got everything duct taped on here because I'm in that mode right now. Got a little rock crawler ESC hooked up to an Arduino Mega, and just to see, what the platform is capable of, because I really haven't messed with these in many years. I used my standard PS2 controller interface because I had the libraries running. So the cool thing is I'm able to actually drive this around and it seems to work. A couple of interesting things I found are that number one, well, there's a bunch of number ones. Basically, it's got so little clearance, I don't think it's going to make it through grass. So I won't have the time to get a hardware platform in time for August, but I'm still trying to see how far I can get just on pavement. So up and down a driveway. If I can do that, I'm going to count it as progress. The other thing I discovered is that it is kind of old, so it's really hard to see in here, or maybe not, but can you see that there's a kind of a paper clip thing through there? Well, there's a paper clip in there because the little plastic or metal piece that used to be in there in this universal joint, it fell out on the test bench. It broke off. I was just seeing how fast the meter spun, and that tire stopped turning, and it was because of that. So tin snip and a paper clip, and now it works again. But it all went back to the point that if you're going to do one of these like we are out in the grass and on different surfaces, you really want to start on a base that's oriented towards torque, not speed, because this is very much more towards speed, not torque. And you want to have sufficient wheel clearance. So anyhow, those were useful things that I found. There was something else that I found. Oh, I know. On the Arduino, I just copied over the same library that I've been using on HoverSim and hacked a whole bunch of stuff away. So let me get started fairly quickly. And I discovered that this is the first project that I've been wanting to use actual servos with. So PWM to control something with, either the speed controller or the servo. And well, I discovered that the standard hardware library has a resource conflict in the timers with something else that I'm using. I don't know which of the library that I had. So I wound up swapping that out for this Adafruit soft servo library. And wouldn't you know that it works, but you'd better not use too many console logs because then it really screws it up. So as a result of that, I'm now introducing something I call DTBW. So this robot in all of its glory is called DTBW. Anybody care to figure out what the acronym stands for? Duct tape and baling wire. Okay, so that's DTBW. Here we go. And that's all that I have to report.
It looks good to me, man. Gordon,
not quite all that I have to report.
Ship it. It's good. Ship it.
Oh. The speed controller box makes a perfectly sized test stand, so that's really positive. The other thing is then that the LCD display for my OpenMV cam came in.
Cool.
So I had a soldering party and I managed to get it all gussied up. But then I'm looking at this and I'm thinking, well, it's a nice little assembly, but it's really not meant to mount anywhere because it's got these two holes in the middle of free space. So anyhow, that's why I call it duct tape and baling wire. So this will be duct taped on with cardboard or something somewhere.
Yeah, they sell a plastic case that you can attach to.
No.
It's reasonably priced.
Yeah,
Okay.
a bracket. Yeah, I'm with you. Whether it's aluminum or Delrin Murray, I'm with you. Or 3D printed, or you know, forget the 3D printing when you've got gaffer's tape. Okay.
Dude, no. That gaffer's tape is too good for that RC platform, man. I'm telling you now.
Okay, you might have a point. But
One and put it on another.
I have a tolerance for slough, but I really don't. I want it to at least make it to the edge of the driveway before falling apart.
Just use rubber bands, man. They're stronger than gaffer's tape if you use the right rubber bands.
All right. Well, that's my update, such as it were.
Yeah. There's the plastic case for it, which you can buy.
Oh.
I would definitely look on Thingiverse. There's most likely
I'm sure of it, but
printed, you know, a case.
Does it hold the display?
Say it again.
Can you attach the display to that on the back?
Yeah, I can. I just had a 3D printed, you know, I drilled 2 holes and there's
bracket.
You know, yeah, this white bracket here. There's just 2 small screws that go through the back of the plastic case, and that's what holds it. I have got a piece of tape over those. Come on, there we go. Yeah. So you can see the 2 nuts on the back. And I did those, you know, kind of at regular intervals because you always want to play around with the height of the camera.
Huh.
So, and that just stood on. I actually have it extended up because I wanted it higher with their. It's not a Rector set. It's like a knockoff of a Rector set that I got years ago from Big Lots. They had them on sale, and so, but it works pretty good.
Cool. Well, thanks. I'll have to add that to my shop list. All right. We seem to have flown around the table once or twice in record time. How can we be talked out so soon? All right. Well, we'll going once.
Oh wait, what? Okay, whoa. There was a little flurry of messaging on the mailing list, and it was basically me announcing that Pimoroni has finally put on sale the, what's it called? The PAA. Anyway, it's the near optical flow sensor, the one that is for robot vacuum cleaners. So, and Kareem and I had a little back and forth about that. And I think they're around 15 pounds or something. I can't remember. They're not cheap, but I'm going to have a blog post posted. I've got it like half written, but I've been kind of I've got a flooded basement and a whole bunch of other stuff going on around here. So I haven't had a lot of time, but I can highly recommend the investment of at least one of these. And Kareem has suggested he's going to, or he has or will put in an order for them. But I think that we all owe it to ourselves to try one of these. They're basically 10 to 35 millimeters, gives you an optical flow XY coordinate interrupt off the thing. It'll start sending data as it senses movement. And in the gist of it is that the PNW 3901, which is the one that was designed for drones, has a 90 millimeter minimum and doesn't do a great job of accuracy. I would say that it's worth playing with this thing. I've seen that on a consistent surface. In other words, you calibrate it for a certain number of ticks per meter on, let's say, a wood floor or whatever. It's very accurate at that. Whether it goes across from wood floor onto lawn and then onto concrete, you get slightly different numbers. The new library is a lot better than the PMW 3901 library, the one that's designed for this chip. And so it's actually pretty good. I can recommend it, and it's now on sale at Pimoroni. And I don't work for Pimoroni, nor do I get any kickback. But thought I'd throw that in there, and maybe Kareem can add something once he's seen it and had a play with it. Anyway, that was it. We can call it a day.
Oh, that's cool.
Well, wait a minute. PID. I got to say the word PID.
Oh,
Yeah, that loop just got a long time constant there, Harold, on your PID there.
well, speaking of PID, I'm really looking forward to David's presentation on Sunday morning, like at 4:30 or 5 in the morning, whatever the hell it is here. But I'll be up early because I'm not going to miss that one. So.
That's cool. He's going to go for a while. We had a little practice session, so he's doing his best to cover quite a lot of ground, but in a very approachable way. And yeah, I'm looking forward to it as well. It's one of those things where I don't know about anyone else, but I've heard him give parts of this before over the years, but it was at a time when I was focused on something else, so it really didn't sink in. I didn't think about it in a certain way, and now after the last couple of years, I think I'm ready to soak it up and put it to use.
What event is that?
It's this Saturday at I think 1 o'clock Dallas time.
Okay.
Is it a meeting like this one or?
Yeah, it'll be the same. I think it's even the same meet URL. It's in the D list or
yeah, it's this one.
Yeah.
You know, I didn't see any of those emails on the mailing list, and I don't know if I'm on the mailing list. I thought I probably should be, and could somebody check to make sure that I'm actually on that?
Well, it did show up in the mailing list. That's where
Okay.
In fact, the link that I clicked into this meeting from was actually from that announcement. So it's just the same.
I may just be missing it because sometimes I get a plethora of email and it turns into white noise sometimes. So I'll go look again.
If you've signed up for the club and
yeah,
and Doug, I don't know what other requirements you'd have to do to get on the D list, but
you go to the website and let's see, you go to the information tab and you go down to mail list.
I don't even know if I've got an actual login on the site.
And then there's a link to join the mailing list. Okay. Well, I can check here probably in a little bit.
Okay.
And see if you're in it already. Okay.
I go to member login. I don't think I know what that is. Well, maybe. Hold on.
Are you getting the Tuesday meeting notices?
I am. So maybe it is getting. I just didn't recognize.
Right. It came out from the same source.
Okay. I guess I can log in. Holy moly! I'm about to see this.
Another login, Harold. Just what you needed.
Well, that's what I'm using my LastPass for. My last password. I don't even know what the password is of this thing, but something does somewhere. And yeah. Okay.
I did have one question, a technical question you guys might be able to help me with. One of the things I've been talking about is, let me get a wheel, is on a robot, like a Mars rover, there's that idea of having a long cylindrical wheel with a motor inside, and then there's this bracket that goes around and up onto the steering connection, and that I've been calling it a U bracket. And I'm still kind of working through the possible options on that, and one of them is make it entirely out of aluminum, one's out of plastic. The question is, if I had the piece coming off the back of the motor made out of aluminum, and then I had some kind of a thing coming up, if it was two pieces of PC board, would that work? Does PC board handle shock at all, or does it just start to delaminate?
You would have to have enough strength to make it's torquing the wheels to turn it, so it's got to handle that torque strength too.
Well, I'm thinking two pieces of PC board that come up, basically a U shape, a square U, made out of PC board, and then the rest of it would be all aluminum. But the actual U shape would be two pieces of parallel PC board.
Yeah, like if you had two C-shaped PC board with standoffs in between.
Exactly.
You know, and I've seen there's I can't remember where I've seen it, but there are some projects that are made with exactly that kind of construction.
Okay.
Like you know those boxes you can do on a laser cutter where they just kind of fit together and then with a couple screws. Well, I've seen people do that with PC boards.
Well, Fortronics, which is a British company, a small robot company, Fortronics actually makes a very tiny N20 based, or no, they use small servos. They sell a Mars rover, a tiny Mars rover made entirely out of PC board. It's not cheap. It's like 120 pounds or something like that, but it comes with micro bit Arduino or Raspberry Pi, but the actual rover is made from PC board. And my rover is not going to be a lot bigger than that, but I want it to be pretty durable. I'm not going to make it out of 3D printing, by the way. I'm going to try to make it solid enough that it can actually handle a whack. And
Come
so
over to the dark side. Come over to the dark side, Murray. Over to the dark side.
Well, if you use a copper-clad PC board, then you could have your ground plate, Faraday cage, and a little steampunk action all in one.
So you guys don't see any delamination. You think that PC board would be plenty strong? I mean, it's fiberglass, right?
Are you talking about like a printed circuit board with a right angle in it or something?
I'm just talking about using PC board as a building material.
As like flat sheets.
Yeah,
whatever you can do with a flat sheet.
Yeah, and I would just cut it by hand, I guess. In fact, it's almost cheaper nowadays if I went ahead and actually had them manufactured as PC boards from China. It'd probably be actually a lot easier than cutting it myself. So
use their CNC, cut it to shape.
Exactly. Yeah,
Why not?
Exactly. Because I never got I tried to find a local CNC place, and the guys didn't even bother to get back to me. Apparently, it's too small a project. So.
Well, see there, and here's another thing, Murray. If you did it that way, I know Doug mentioned earlier wanted to go to this design to part show to look at options for simplifying wiring. But if you use printed circuit cards, right, as the clamp that gets down to your motor, why not embed the traces for the motor in the circuit card? Now you don't have any extra cable. You got a connector at the top and a short jumper at the bottom.
Well, and it's actually six. No, it's actually 6 wires because I got the motor encoders as well. So
sure,
yeah,
it's a circuit card.
I can even make thousands of them and sell them.
PC boards are basically epoxy resin and fiberglass, right?
Yeah, it's very strong.
I'm just wondering if that will flex without shattering or not shattering, but maybe
that's my only fear is the delaminating. But I think it's probably I mean, my whole robot's meant to be kind of this big. I started to try to classify robots, and it's bigger than guinea pig, and I think it's about the size of a chicken, but smaller than a dog, so it's chicken sized.
Well, I've got some fiberglass that's basically printed circuit boards without the metal clad on it, and it's very strong.
Okay, I might give that a go then.
Hey, Doug, you kind of expressed a concern about wiring and stuff. Have you ever used wire wrap wire for like simple boards and stuff?
Yeah, early on when I was in college, for example, we used some wire wrapping. I mean, Ron Grant has used a lot of wire wrapping.
Yeah.
I actually at one time had wire wrapping tools, but I don't have them anymore.
You mean like this?
But
yeah.
But
the only downside, go ahead, Doug.
PC boards are so much easier. I wouldn't go that way.
Yeah,
I agree. You remember, I usually hand make a PC board here using a toner transfer method before I would send it off. But what happens is I usually only need one. But when I got my prototype made, it usually ends up in the robot. So, but I like the ability to be able to, I don't like using anything that's a nest of wires. I find it's easier to sit down, draw the schematic, make a board in KiCad, and just do toner transfer and make it, because I'll have it in 2 hours.
Mm-hmm.
Okay, and if I usually you're close enough that if you have to make an adjustment, you can either gray wire it, or I should say blue wire it, or you can do something weird with it, cut traces, and then you just from one more run if you want to make it nicer. I just find that so much easier than say one of these sea of contacts where the guy's got wires going all over the place. I don't even just cutting the wires, it's just painful. So I have to say I haven't done it. I've done it all. It just depends on the project.
Kareem's point is the one I was going to make, which is that wire wrap is really terrible if it's got any vibration at all. They'll just delaminate right off of the wires.
Yeah, they used to make. I've even made one where they used to have a product where they had a spool of essentially enamel wire, and you would go to wherever your connection point was, and just hit it with solder, and it would melt the enamel. And so you were essentially running this really thin enamel wire from point to point, and I mean it works, but I just rather not do it.
Yeah.
That brings back memories when I hired on E-Systems, which is now part of Raytheon, back in the mid-'80s. All their boards, their prototype boards, were done with wire wrap wires, with hundreds of wires on the board.
Well, Doug, the way I've been dealing with it is I've built as you know, I've gone ahead and used the DuPont connectors, and I just make wiring harnesses, and the wiring harnesses are sort of my APIs in the sense that whatever's at the end of that I've documented, and then I've got a wiring harness that I've tested, and then I've just got a whole bunch of these things, and I've got a nest of wires. I mean, whoa, I didn't realize I was connected. Hold on. There, okay. But I mean, I've got a nest of wires there, but it's a whole bunch of wiring harnesses, so it's not so bad.
Yeah, that's a nicer way to do it. I've also seen something that I like, that I haven't done this, but I like it a lot. The idea of it a lot is that we all have these Chinese modules. Boost power supplies, different sensors and all. And what they do is they lay out basically a motherboard for those particular modules. So the wiring is on the board, and you don't have as many of the wiring harnesses. You still have wiring harnesses, but you don't have as many. And some of them are even going in and clipping the holes so that they can use the technique like they use on the Wi-Fi sockets, where it's literally on the board and they just solder it up. So I've been looking at that as a way to, because you can't buy the parts for some of these modules. The module's cheaper than, they've already figured it out, got the circuit, and you couldn't buy the parts for the price of the module. So sometimes they do something like you don't like. For example, a lot of the sensors won't bring out the analog pin, which they could have done, except they were cheap out and they didn't want to put one more pin on it. But figuring out a good way to wire stuff is tricky. Yeah.
Well, one of the things I need to do, and I keep thinking about it, but I don't need one more project, is actually investing or getting some free software and actually starting to make my own PC boards, just because the cost is so low now, and the turnaround time is pretty fast. And if I did my own PC boards, like there's one of the guys that I've met, his name's Alexander. I think he's in Long Island, New York, I think, and he's a maths teacher, and he's built a whole bunch of PC boards on his own. He's done, power, motor controllers and all sorts of stuff. And he's even offered to help me. I think John did the same thing, offered to help me get going on some of this software. But it just seems like nowadays, like you said, Doug, it doesn't make a lot of sense to have a whole bunch of wires everywhere if you could just make up a quick PC board that did the trick. And now this idea of using PC boards for construction also, it might be a lot cheaper than trying to hire someone like CNC or anything to do something that's actually structural.
Yeah, some of the guys in the club, David Ackley, John Kay, that have bought little CNC mills that are suitable for making PC boards. They just mill out the traces. I use the toner transfer method for most of my projects because I don't, like I say, that's how I prototype. But the making them, like you said, you can get 5 boards for $5. I mean, it's crazy the prices you can get these professional PCB boards made. but I don't like the idea. Even the fastest of those is going to take you probably a week to 10 days.
Not in New Zealand, it won't.
Yeah, but I'm just saying is, most of them, you take them, you send them over there, and they have to make them, and they're making big panels, and so your job fits into the big panel, and then they make it, and then cut it up and send it to you. It's 7 to 10 days, unless
Go ahead. I'm sorry.
Unless you want to pay big shipping. You pay $5 for the board and $40 for shipping, then you can probably get it in 3 or 4 days.
Yeah, but one of the things I've learned about. Go ahead, Harold.
I'm sorry. My big problem with all of this is that it's this thing called planning, because I'm not sure how I want to build a thing or what I want to do with it. And in order to make a PC board, I'd kind of really want that. So until I know what I exactly want or know what I need, because I've been trial and error on finding out, oh yeah, now I need one of these, let's go make a PC board. Then I'm all about the PC board. Let's go figure that out, right?
Yeah, chicken and egg, right?
Yeah.
Yeah, well, I would say that that's the reason why I like to do it, because I use KiCad, but the people use Eagle. Your first step is to write your circuit, okay, design your circuit. And one of the big things that the next step is you actually run it against some tests to make sure you haven't forgotten the wire that goes from pin X to 5 volts or whatever. You eliminate those type of mistakes, and it forces you to really know what you're going to do. And so you spend a lot less time in that portion of the project. And now I know what Harold's saying. He says, well, dang, I don't know if I want 2 ultrasonics and 3 sharp sensors, or do I want 5 sharp sensors, or do I want, a couple extra LEDs or whatever.
Maybe it's a need, because 1 is good, but if I had 3, I could really do something great, and I don't know that until I get there, right?
Well, but the thing is a lot of those external sensors don't need to be on the PCB.
Agreed.
All right. So what you need on the PCB is access to the pins that you would need to program, that you would need to attach to that sensor.
I'm thinking more of interposer boards. Give me, I want to plug this thing into my GPIO or some other kind of thing, plug something into that, and have all the various pins and stuff just to plug all my crap into. So I'm not running wires everywhere. That'd be what I'm envisioning right at the moment.
Well, but Harold, you can't just use like a prototyping board. I mean, they make them in all different sizes. And
I'm thinking about that too.
what I'm looking at is that in terms of the boards I'd be talking about would be literally structural boards that might have the motor and encoder wires on it. And so I'm looking at this very expensive Lego kit from GoBuilda, the hardware from them. I'd be using most of their hardware just to kind of get the basics together, which I've kind of done with Imperial units. So now my next order is 1/6 of a Mars rover. And if I can get that working and figure out what to do with the wheels and this C bracket, I guess we'll call it, that's kind of 1/6 of the robot that I need. And then we're done in terms of then I need to come up with another $3,000 or whatever it's going to cost me. But the design is, I have to say, yeah, chicken and egg design is really hard. How to get to a point where you're willing to invest a lot of money on an expensive robot in order to build it the first time, knowing that it's probably not going to be right the first time.
Hey, Murray, I've got an example for your initial question about using a PCB board for structural integrity. I've been using this PCB board as the chassis of this car for many, many years.
Oh, yeah.
I don't know if y'all can see.
Yeah.
Hold
the edge so we can see the thickness of the chassis board.
It's just I'd say it's probably a 0.062 standard circuit board thickness.
1/16 of an inch.
Yeah, it just occurs to me that my brother and I had RC cars back in the 70s, and I think they had a PC board for the chassis as well.
Yeah, a lot of them had just a thin piece of fiberglass, and then it's got another thin piece on top that has the stanchions connecting the two, just like what you're talking about with your C bracket.
And I'd never have as much shock on a robot as you would on an RC car. That's for sure.
Right. And I have no damage to this at all, except for just scratches on the bottom from
Yeah.
low bite height.
Okay, I think that means that I might have to invest in some learning how to use PC board design software and maybe I think it's called GC. There's like a 5-digit or 5-character company in China that a lot of people use, JCBC something.
Yeah, I've been hearing a lot about JC, whatever. And, they, from what I understand, they got a pretty easy system to use.
Yeah, so I might have to give that a try because that seems to be the easiest way to make these C brackets. I still haven't figured out how to make these cylindrical long tires or wheels, but
That offer to do CAD training is still open, Murray. Whatever you want.
okay, I might have to take you up on it because actually I could theoretically make the cap of the wheel out of PC board and then have like stainless steel tube or something. But yeah. Put it this way, anybody making an exomi, a whole robot out of 3D printed plastic is going to be a lot less strong than what I'd make out of PC board and aluminum. So,
hey, also, circuit board design is something that I do at work. So if you were ever wanted to just send me an email with like a hand-drawn sketch with some dimensions, I could very easily draw something up and send it back to you and give you the Gerber files that you would need to send to a fab house.
That's a very nice offer. I might take you up on that.
I mean, because from what you're talking about, it seems to me like it would be maybe like a hour of work or whatever.
Well, even if you did the basics, I could then not clean it up, but I'm a graphic artist, so I might tweak it, make it look nice or something like that, and add the traces. But yeah, it's a very generous offer. Thank you.
Yeah, no problem.
Well, routing your own traces is all part of the fun.
Yeah.
Harold, I checked. You're not on the mailing list.
Okay, I just got signed up. Thank you. I was in the process of signing up, and I got some email somewhere, and I'm looking at it right now.
Okay.
How did Harold become persona non grata? I mean, I wonder.
I've been kicked out of better clubs than this, I'll tell you that.
I've been kicked out of better organizations than this one.
It's nothing personal for anyone who's had that happen. I think it's the mailing list equivalent of duct tape and baling wire.
Yeah.
What's the Groucho Marx quote?
I wouldn't be a member of any club that had me as a member.
That's the one.
Nice.
Thank you, Harold. That's the one I was looking for.
I'm glad I could. A veritable cesspool of knowledge in my head and also in this group. So somebody's bound to know that, right?
Yeah. All right, I got to call the local council about my flooded basement, so I got to go. So, see you guys. Well, I won't be here next week. Sorry, I've got to be in a hospital, unfortunately. So, not me, but my partner. So,
good luck.
Anyway,
good luck with
see
that.
you guys in a couple weeks.
Take care, guys. Have a good night.
Bye.
Yeah, bye, guys.